So increasingly, the apps we write are being used not by humans, but by other apps via their APIs. These other apps are written by humans, though. Rivo Laks is a software developer and systems architect, and he's been working with Django since 2011. He's going to tell us how we can make our APIs well-designed and easy to consume for other developers. Please make Rivo feel welcome.
Thank you, and good morning. So I am Rivo, and this is my talk on how to create solid APIs. Our applications are increasingly being used not by humans, but by other applications via their APIs. APIs are eating the world, they say, but ironically, APIs themselves are first used by other people, the developers integrating with your application. And that means that your APIs must target not just the machines, but even more importantly, humans as well. I come from Estonia, and up until a few months ago, I was part of Thorgate, an Estonian product development agency working on a variety of products and projects built with Python, Django, and other technologies. And this talk was inspired by one of those, where API had top priority from day one. The focus was on creating a platform for managing forestry-related data. And other developers had to be able to interface with it, fetch data, do various operations. And the official UI also had to be built on top of the publicly available API, which meant that all of the functionality had to be available over the API. And as most developers, I had used and even created APIs before, but this project had higher demands. And so it got me thinking, how should I approach this? And what are the guidelines and the best practices to making APIs that other developers would love to use? And this talk aims to share what I found going down that rabbit hole. Let's begin with the definition of API. Usually, API is defined as application programming interface. But I think a better definition might be application programmer interface. Because when you think about it, then APIs are really user interface meant for other developers. So keeping that in mind, let's go back to our API project and look at the goals that we need to consider when creating those user interfaces. We want our API to be feature complete and offer full access to various parts of the system. This means that we need to cater to quite a variety of different use cases and support common features like access controls, pagination, and so on. We also want it to be easy to get started with. And this process should be fully automated, meaning we don't really want any manual verification steps and whatnot. And finally, we also want to make the entire process as smooth as possible, meaning we need to anticipate the potential stumbling stones that other developers will encounter and then try to remove them from their paths. Let's begin with versioning. It's one of those topics that people don't often care about at first, but it's also something that's really difficult to bolt on later. There's a myriad of examples of APIs that did not have versioning at first and then became popular and then struggled to introduce versioning without breaking everything. So why do we even need versioning? Obviously so that we can break things, right? But in a way that we remain in control of those breakages. What I mean by that is you will almost certainly need to make changes. That's natural. But with explicit and planned versioning, you can do that while remaining in control and not just pissing off all the developers using your API. To do versioning successfully, there are a few things you need to be providing to the users of your API. They will definitely want to know how long one specific version will be maintained and remain available. This is really important in bigger projects. And having well-known deprecation schedules is one of the reasons why Django itself is so popular. You will also want to provide information on where the third-party developers need to do changes in their code as they move from one version to the next one. The next question is, how do you specify versions in the API requests? There are different options here, and I'll cover two of the more popular ones. You can have clients specify version as part of the accept HTTP header. In this example, you can see that the client requests a list of projects and then says that they want the response to be in JSON format and use version 1 of whatever versioning schema you use. This is the more idealistic approach because the version used is sort of meta information, which is then kept out of the URL paths. But headers are also a bit harder to use and test in the real world. For example, you can't just take the URL, open it in browser, and test different versions that way. So in the real world, perhaps path-based versioning might be a more pragmatic choice. In this case, we see that the version is now part of the path in the URL, and the client explicitly requests projects listing for one specific API version. And this can make debugging a bit easier as well, because if you log the paths in your server, then you automatically include the versioning information there as well. You might have noticed that I used integers as versions in my examples. Another possibility is to use dates. And frankly, I've started preferring dates myself because they're a bit less emotional, meaning that you don't need to think about whether the next version will be 1.1 or 2.0. Is it big enough to be 2.0? And also, it might be easier to introduce internal or testing versions. For example, you can just create the new version based on today's state and open it up for some specific group of developers without changing anything else. This was about the client side of things, but let's also look at how to handle versioning on the server side. There are two broad categories here. You can have smaller incremental changes or really big breaking ones. And for incremental changes, a nice approach is to use version transformers. This is sort of similar to Django's middlewares. So your core code would only support the latest version. And then to handle the previous versions, you would use the transformers, which know how to sort of translate the previous version of the request data into the next version, and then do the opposite for the response data. And you can also stack the transformers. So let's say that you have versions 1, 2, and 3. Your core code would only handle version 3. And then if a request comes in for version number 1, then one of the transformers would translate it to version 2. The second transformer would translate it to version 3. Then your core code would do the processing, and then the opposite process would take place for the response data. And this makes it quite easy to change field names, for example, or add new fields without affecting any of the old versions. And notably, Stripe is using that approach in their API, and they've also blogged about it. For massive and breaking changes, though, transformers might not work out. And in that case, you may just need to create a completely new implementation of the API and duplicate some of the code in process. And now that we have the versioning in place, let's move on to the next layer. Most APIs don't really deal with just public data, or even if they do, you probably still want to track on who's using your API for various purposes like request limits. So that means that you need to think about authentication, who is the client that is making this request, as well as authorization, figuring out what that client is allowed to access. And again, the best practice here depends largely on the use case. I'll cover two of the major options. The first one is token authentication. This is the simple approach where clients basically send an HTTP header containing a simple token with each request. And token authentication is useful for client-server situations where a client might be a native mobile application, for example, which the user directly logs into. And in that case, the mobile application would receive the authentication token after the user has logged in and would then send it along with all of the requests that it will make. And if you think about it, then session cookies are also basically one sort of authentication token. And perhaps if your API is used only from the browser, then that's all you need. For more complicated situations, there's OAuth 2. OAuth 2 is meant for creating platforms. Think Facebook, for example, where a third-party application can request access to users' data. The platform then verifies this request, asks for users' permissions, and then grants the application a token which is both application-specific as well as user-specific. OAuth 2 is quite complicated protocol. It covers many different use cases and flows, like mobile applications, web applications, as well as applications with very limited UI, like living room devices. And this is good because you'll be using proven standards that have evolved over the years and have already solved many problems that perhaps you're not even thinking about. But the downside is that it also requires quite a bit of attention when you're implementing it. Luckily, there are various libraries available that take care of most of this plumbing work. If you're using Django, there's Django OAuth toolkit. And there's also OAuth lib that the Django OAuth toolkit is built upon and which provides even more lower-level customization options, basically. And for our API project, we ended up using Django OAuth toolkit and then adding some functionality on top of that. Some of this was due to missing features of the OAuth toolkit, but mostly it was just due to the requirements of our application itself. For example, we needed to keep track of some more information relating to the authentication tokens. And we also re-implemented the pages where developers can register their applications to make it more user-friendly. With the bottom layers in place, it's time to move on to the request-response data structure of the API. And the most important point here is to standardize them. Following standards is good because it gives your user a sense of familiarity. If you create something that's completely unique and handcrafted, then your users will have to learn everything about it from scratch. But if you instead follow widespread standards, then it's likely that they already have experience with something similar. And they can then sort of transfer this knowledge to using your API. Just as importantly, standards also have some thought put into them, usually. And they help you avoid common pitfalls. This is quite similar to how Django, for example, implements password storage so that you don't end up implementing something quite insecure yourself. And overall, I think standards just increase your chance of success because when you think about human history in general, then you will find tons of examples on how standardized approaches win out. Money is something that is globally standardized to some extent. We try to use UTF-8 everywhere. And even the fundamental laws are quite similar and standard across different nations. And when it comes to APIs, my current standard of choice is JSON API. JSON API is not just an API that uses JSON for its responses, but it's an actual specification for building APIs. It was created by authors of Ember, and it offers a comprehensive solution to various features that you will need for an API. And I should also stress that it's one option out of several, and there are others that might make more sense for your use case. For example, GraphQL is also a popular option. One of the most important aspects of JSON API is that it defines a generic yet flexible structure for API responses. So let's look at how API responses are structured with JSON API. And I'll be using a sort of project management tool as an example application here, which lets users create projects and epics and stories in them, as well as add comments. sort of similar to Basecamp, if you know that one. So here we have an example of a client making a request to get the list of projects. And the response document here has 3 top-level members: the links, the data, and included. And let's go over them one by one. First, we have the links, which is important because they enable discovery of other related endpoints. In this case, we can see that to get the next page of results, we have to just follow this one URL. And in the same way, your API route should offer links to the individual resource pages, for example, this projects page, so that instead of hard coding everything, the clients can just go and discover those. Next up, we have data, which contains the so-called primary data, which is the resource or resources that you asked for. And in this case, we asked for a list of projects, so the data is a list as well. And each of those objects here has, first of all, type and ID, which uniquely identified. Then they can also include links. In this case, we specify the canonical link of this specific resource, which you can use to, for example, modify this object, or perhaps ask for full data of one specific object. Next up, we have attributes, which is quite self-explanatory. We have the creation timestamp here, as well as name and description. And resources can also have related objects returned under relationships object. And this is what the relationships look like. We can see that our project has created by relationship, which points to a user, as well as epics relationship, which is list of epics. And each of those, again, has the type and ID, which uniquely identify this resource. And we can use those to look it up in the included resources object, which is the third top-level one. And this is quite similar to the primary data. In this case, we have the epic end user that we already saw sort of referenced in the main resource. And the included resources are important because they can be used to optimize the number of API requests that you make. For example, if we wanted to display a list of the projects and display the author's name for each of them, then in this case, we only need a single request because the author's data is already included there. This is especially important for mobile applications, for example, which might be operating over high latency networks, and you really want to optimize the number of requests that you make there. So how did that feel? Perhaps if you haven't used JSON APIs before, then it maybe looked a bit weird and bloated. If you wanted to receive the name of the user who created a project, then you'd have to go through several layers of indirection. And yet, if I now gave you a response for another object from that same API and told you that it has, for example, updated by field, which is also a user, and wanted to find out the name of that user, then you'd know exactly how to do that because the response would be structured in the same way. And furthermore, if I gave you a completely different API, which also uses JSON API, then you would know how to access that one as well. And that's, in a nutshell, the power of standardization. It brings familiarity and makes concepts that you already know applicable to something new as well. Let's look at a few other features of JSON API. For example, the included data and fields that you saw earlier are actually configurable by the client. So the client might say that it wants the comments to be included, as shown in the second example here. And the third example shows that you can also customize the individual fields returned for each of the objects. This is, again, important if you have, for example, a mobile application and you want to optimize the data that you send over the network. In this case, you can ask for just the data that you need. You already saw the pagination. Basically, it works by having next and previous URLs in the response. And this is very nice for clients because they don't need to know about how you implement pagination internally. They just have to be able to take this one URL out of the response and then follow it to get the next page of results. In the example, I used cursor-based pagination, which is nice, but in some cases, you might prefer a different style, for example, page number-based. And again, you can actually change that within the server without clients noticing, thanks to the pagination working via URLs. Let's also talk about errors. Errors happen, and what you should do is just making it easy for users to figure out why something went wrong and how they can fix it. And once again, the goal here is to reduce friction and make it faster and easier to solve the issues. So here's an example of a client trying to create a new project and something going wrong. And we can see that the API basically returns a list of errors, in this case, a single one. And the response contains both human-readable data that you can show to the user, meaning the end user, as well as machine-readable data, in this case, pointing out that name is the field that had some problems, and name too short is the error code. There are also some special cases. For example, you might want to transmit a large amount of data. And in that case, perhaps a different, more specialized format makes more sense than using JSON API. But the even better solution might be to include link to the downloadable data in your main API response. And you might remember that JSON API already has this links object that could also contain links to various secondary data download points. So here we have an example of a client trying to access some data sets. And the result is basically metadata, which then also includes in the links section URL of the raw data itself that you can download. And the additional benefit of this is that you can store your data outside of your application server. For example, you put it into S3 and then just store the link in your main application. So to reiterate, standardization matters. It's good to use things that your users might already be familiar with. And what specific standard you use is a lot less important, in my opinion. I like JSON API. If you like GraphQL, then that could be a perfectly good option as well. Finally, let's get to perhaps the most important part of all, which is documentation. Documentation is too often overlooked. We don't really want to do this. It's not the fun part, right? At least when you're developing. But when you're trying to make sense of something that was created by others, then documentation becomes much more important and valuable. And I think if you don't document your code or your APIs, then you're just a crappy engineer. Docs are also often the first point of contact that people have with your API. And thus, they might decide whether to stick with what you're offering or keep looking. I do the same myself when I'm looking for a solution to some common problem. There are often quite a few options available, and then the impression that I get from the README and documentation is quite important deciding factor. And documentation does take effort, and I admit I'm not that good myself at it, but that does not mean that we shouldn't try. And if you only take a single thing from my talk, then let it be this. Just put some good effort into your documentation. So how do you go about creating those awesome docs? Documentation is a bit like selling page for your API. It needs to convince the potential users that this is the thing to use. And the good news is your audience is other developers, which makes things a bit easier. So what should go in there? First of all, I want to know how to access it. This means that I also need to figure out if I need some special developer account to sign up for. If you do, then it's always helpful to offer some sort of demo account or API key that I can just start using right away, even for some testing or example purposes. I also want to know what the URLs are, the root URL. And I want to know if I have to provide any sort of authentication. For example, are you using OAuth? There is also a lot of mundane stuff that often goes overlooked but is nonetheless important. For example, what character encoding you're using, what format are you using for timestamps, and so on and so forth. This is especially important when you're approaching either those with less experience or those that live outside the Python world, where some of the conventions that we are used to might not be as apparent. It also helps to give a quick overview of how versioning, pagination, and all other sort of common features work. And I also want to see some common errors and solutions to those, which make it easier for me to find out that I'm dealing with, say, authentication problem. And it always helps to provide code that I can just copy and paste somewhere and have this first example working right away. Then you will probably also have a bunch of endpoints for different resources. For each of those, it helps to point out the URL as well as operations that you can do with it. For example, creating them, modifying them, just reading them. I also want to know what the request and response data looks like, especially important for modifying, because I want to know how I have to send the new data. If there are any optional parameters, for example, for filtering the list results, then those are useful to point out. And if permissions determine the results or returned objects, then it helps to point out that administrators might, for example, have access to more objects than ordinary users. And the only thing that's worse than no documentation is obsolete documentation. Inconsistencies, for example, between the documentation and actual API, they don't only make the documentation useless, they basically undermine trust in your entire API. And it helps to auto-generate the documentation here. So usually you create some sort of schema, meaning machine-readable description of your API from your code, and then you generate the documentation based on that. And there are different options available here. OpenAPI, also known as Swagger, is perhaps the most well-known one. And you should just try to figure out what your tooling uses. If you're using Django REST framework, then there are quite a few options available for sort of integrating with OpenAPI and then offering auto-generated documentation. And again, you'd want to combine docs and code in the best case. Another interesting thing about machine-readable schemas is that you can also use it to auto-generate client libraries. So, for example, generate Python package for your API, but also generate the same thing in different languages. So let's sum this up. Standards bring familiarity, so you should pick one and stick to it instead of trying to invent something completely new. Documentation matters because it gives your users the first impression. You should use automation as much as possible to ensure that your documentation is always up to date, and you can use the same for creating client libraries. And in general, just reduce friction as much as possible, meaning get rid of all the little bumps along the way and the issues that drive your users and developers away. So think of the humans. I will not be taking questions, but feel free to approach me anytime afterwards. You can also find the slides at the given URL. And thanks for listening.